Okay, this is just a little do now, I guess, for what we talked about yesterday, because I don't like to leave that hanging. I don't think you guys really understood. I know Gordon was confused. So I came up with this scenario, and I hope that this is going to make sense to you. So I came up with this picture. This is the function y equals x squared. So let's start here. When x equals 1, what is my location? It's 1, because y equals x squared, so if x is 1, y is 1. So that means I'm right here. Okay, when x is 2, where am I located? I'm at 4. Okay, this is all really obvious, right? So let's just take this question out for a moment. Okay, so what if I didn't have the original function? Like in the problems that we did, we didn't have the original function. We had a derivative. So the derivative of x squared is 2x. So what I'm saying is that you can do the integral of 2x dx from 1 to 2, and that's going to tell you where you are at 2. So if the question says, where are you when x equals 2, you can do the integral from 1 to 2 of the derivative, which is 2x. So if you solve this, I want you to see how it works. We get this. Okay, but these 2's cancel. So you're going to get 4 minus 1 equals 3. And it would appear that it's 3, but it's not 3 because we have right here that it's supposed to be 4. So let's think about this for a second. What we're saying is, if you start at 1 and then you travel 3, if you have this function going from 1 to 2, we don't know where we are, so let me go back and just change this to yellow, sorry. So you do not know that when x equals 1, you're at 1. You're just being told that where are you when x equals 2. And so if we do this integral from 1 to 2, we're going to get that we were at 3, which we know is wrong. We know from this we should be at 4, because if you put 2 into x squared, you get 4. So what's missing? The extra 1. And that's because it's giving us the distance from the axes to how far this is, which is 3. But what it didn't consider is that you were already at 1. So if you were already at 1, wouldn't you be a little bit higher? So all you need to do is to find the integral of the function. You'll get the 3, but then you have to add, if you're starting at 1, where were you at 1? At 1, you were at 1. So you have to do the 3 plus 1, and the answer would be 4, which we know is right. So, for example, for this problem, I couldn't find the distance from, let's say, 0 to 2 because I don't know where I am at 0. Now, in this case, if you actually did that, so I'm going to change this from 0 to 2. That's just going to change this over here. Then you're going to get 4 minus 0, which is 4. And the reason why this works is because I was at 0. But because at 0, you're at 0. So it's just measuring the distance from the axes straight up to here. But the problem is if you don't know where you are, this is a beautiful function. Just, 2x is the derivative. If it's something more complicated, that's not going to work. So when we did the problem today, we had to add, I think it was, we were adding a 5, and we had to do that because you had to know where you started. From the problem today, we had something about where we knew where we were at 8. So for this parabola, so if we look at this a little differently, let's get all this mess out, make it nice and clean. Make this nice big parabola. So let's say that I want to know where am I when x equals 2. And the only thing that I know is when x is 5, I'm at 25. This is still y equals x squared. So if the question is where am I when x equals 2, then I would do, I need to know where I am. So the only place I know where I am is at 5. So I would do the integral from 5 to 2. So I'm going to be traveling like in this direction of the derivative dx. But you can't have the bigger number on the bottom, so as we said today, we're going to flip them and negate it. Okay? Find the antiderivative. And don't forget there's a negative in front. Okay, erase this to make some room. Okay, the 2's cancel, so I have a negative, and then I'm going to do everything else. So if I put 5 in there, I get 25 minus, and then I'm going to put 2 in there, and I'm going to get 4. So I'm going to get a negative 21. Okay? But where was I at 5? At 5, I was at 25. So I have to add 25 to that, and I get 4. Well, when x is 2, isn't y 4? So it works no matter what, no matter which direction you go in, but you always have to know where you are when you started. So I hope that clears that up a little bit.